Hi everyone, today we are going to learn all about RAG in just 4 minutes. First, let's look at the problem statement so we can understand exactly why we need to use RAG. The problem is that when we ask a question to any AI model, it responds based on the massive dataset it was originally trained on. If we want to ask about information present in our local files or a company's private documents, the LLM won't know the answer. This data is not present in the LLM's database and the model was never trained on it. So, what happens in this case? Because the AI doesn't have access to our data, it will either give a random response or try to piece together matching data that might not be correct. This is exactly why we use RAG. What does RAG do? First, we store our private data into a vector database. Then, when we ask a question, the system fetches the matching data from that database and uses it to return the perfect output. Today, we are going to learn this entire process deeply. So, to start, the most basic thing we need is a vector database. What is vector database? A vector database is a specialized database that stores data as numbers, which we call embeddings. Our very first process looks like this. Whatever data we have, whether it is a PDF, a web page, an Excel sheet, or any other type of document, we first divide into chunks. Why we need to divide? So because we cannot embed all the data at once, based on specific conditions, we split the data into smaller parts and create their embeddings. This means we convert the text data into a numerical form, and then we store those embeddings into the vector database. This is our first and most important step. After that, we have the runtime process when a user asks a query. For example, let's say I ask, how many people in my office are over the age of 40? First, this query is also converted into an embedding, meaning into numbers. Next, we execute our first major step, that is retrieval. Based on similarity search of our query's embedding, the database finds the closest matching elements. Usually, we look for the top 5 closest matching elements. We can configure this value, that is kth value, to be anything we want. But for this case, we will set it to 5. So, we have completed the R step, that is retrieval. And we now have our 5 chunks of data. The next part is augmentation. In the augmentation step, we combine our system prompt with the retrieved data chunks and the user's original query. Finally, in the last step, we send this combined package, that is the user query, the system prompt and the retrieved chunks, to the LLM. The LLM then reads the retrieved data and generates final answer, and that is how RAG works. We use this architecture primarily to reduce the hallucination. Hallucination happens when an LLM gives you incorrect data but states it with the absolute confidence as if it were correct. RAG fixes this problem. So thank you so much for watching this video. If you liked it, please make sure to like, subscribe